And now we're going to go into another segment talking about a deep dive on accelerated computing instances on EC2. And so just as a quick recap from our previous session, the overview of the EC2 instance types, we have a variety of different options for you to meet your needs in terms of general purpose compute, which is such as our M5, our mainstream instance 5, compute optimized, like our C instance types, like C5 and C4, and then storage optimized instances. These are ideal for things like analytics and for storing large amounts of data and processing data. And then memory optimized for in-memory databases like X1E and R4. These are great for things like SAP HANA workloads and others. And then we also have mentioned in brief, but we'll go into more depth in this session about our accelerated instance types, which are things like our P3 instance for machine learning, our F1, FPGA, and then G3, which is a graphics instance. So that's what we'll be focused on in this session. OK, so let's just take a look at an overview here of what we're going to cover. So at the top, first of all, our P3 compute instances. These are the fastest machine learning instances that are available. And they have up to 8 NVIDIA V100 GPUs, each with 32 gigs of memory. And they have NVLink for peer-to-peer communication. This enables faster communication between the different nodes for machine learning workloads and reduces the latency. They support a wide variety of use cases, including machine learning, but also HPC simulations. We've had customers using that, like Schrödinger is doing drug discovery. Their clients do drug discovery using HPC on P3. And financial computing, risk analysis. Then we have our graphics instances, our GPU-based graphics instances. G3 is the latest in that line. And these support up to 4 NVIDIA GPUs and can be run in the grid virtual workstation mode. And these are great for 3D rendering. This is also can be virtualized, so you can support many clients simultaneously. And it's great for any graphic-intensive workload. And then we'll talk about our field programmable gate arrays, or FPGA instances. These enable tremendously high volumes of parallel compute, and we'll get into more depth about that. But they include the Xilinx FPGAs, up to 8 of those in a single instance, and now support OpenCL. And so we'll talk about that here in a little bit more depth. OK, so first of all, just at the highest level, the difference between CPUs, GPUs, and FPGA. So CPUs have many cores and arithmetic logic units, or ALUs. And those can be run in parallel. And so it enables a very flexible and broad instruction set. And it has a set data path width. And this is great for general purpose computing, where you need to do such a wide variety of different things. GPUs enable more parallel processing with thousands of parallel ALUs and processing cores. And this is great for operations that are more limited in scope, but can be parallelized for faster throughput. And this is great for things like graphics rendering for machine learning. And then FPGA actually has millions of these programmable logic cores. And they don't have a fixed data path width. So you can change it from, let's say, 8-bit or 7-bit. You can define it so that you're maximizing the usage of these programmable logic cells and taking advantage of potentially hundreds of thousands or up to millions of simultaneous small operations on these FPGAs. So it's a hardware-timed execution, and you have the ability to set that data path width. So a lot of flexibility in terms of how you define it, and a lot of parallel processing possible. So let's start with the P3 and dive into this. So the P3 instances gives you up to a petaflop of compute performance. So the new P3 is now up to 14 times faster than the P2, the prior generation. And with 300 gigabytes per second of GPU to GPU communication through that NVLink. And that's about 9 times faster than the P2 instance, the prior version. So with 16 gigabytes of GPU memory and up to 32 gigs on the very latest instances, and 900 gigabytes per second peaks GPU memory bandwidth, it enables you to process a lot of data in parallel. And we're seeing a wide variety of use cases by our customers. So a couple of examples, Airbnb is able to use P3 to help their hosts optimize the price that they list their real estate for by leveraging machine learning on P3. And they can process this much faster and stay up to date with the latest market trends. We're seeing examples like Salesforce is using machine learning for image recognition. So they can look for example, your logo in certain places to measure impact and impressions. They can use it for detecting, for visual search, for identifying your product as well. And so this can be really helpful for sales teams. And then we also see examples like in Western Digital. We talked a little bit about them designing, doing material design and measuring performance of those materials with simulations. And Schrödinger doing chemical simulations for their customers who are doing drug discovery. But it can also be used for weather simulation, computational fluid dynamics. We've seen it used in oil and gas for seismic analysis. So a wide variety of potential use cases here. OK, so here are the details for the P3 instances. So they're available across 8 different regions. So we've got a lot more availability of P3. And now with support for all the major frameworks, such as TensorFlow, MXNet, PyTorch, Caffe2, and CNTK, it really makes it more flexible for our customers to be able to run the kind of machine learning they want to, but really accelerate the pace at which it's done. And so what we're seeing is customers are able to dramatically reduce the time required to wait for results. So one of the things to point out is on the P3 instances, the new GPU to GPU communication is really improved with NVLink. And that's part of what's delivering a lot of the faster performance versus the PCI Express in the prior generation. So as we look at P2 versus P3 performance, when you look at like mixed performance, mixed floating point, mixed precision floating point, we see about up to 14 times faster for P3. And part of the reason for that is the support for mixed performance and half precision on P3. And then when you look at single precision FP32 performance, still a 1.7x improvement. And then for double precision, over 2x improvement in performance. So big increase in performance with the P3. And then we've just recently announced the new larger 24 X large. So this gives you 32 gigabytes of GPU memory. That was a big increase in total memory available. Much faster networking with up to 100 gigabits per second. And that's where we're seeing some of our customers really push the limits, like fast.ai. And 96 Skylake CPUs. So you've got AVX512, which is great for inference and machine learning and training data, pre-processing training data. So now you've got an instance that can really push the boundaries of what was possible in terms of performance with machine learning. The processors are 3.1 gigahertz, scalable, Skylake Xeon processors. And in terms of scaling performance, what we've been able to see is using a single P3 instance with Volta GPUs, customers are really reducing the training times for their machine learning models. And we've seen it go from days to just hours. And when we talk to our customers who are doing that, like Intuit, to find out, like, what does that mean for you? It means their development teams can have now a much faster iteration cycle. And they can try a bunch of new ideas much more quickly. And that's what we hope to enable for you with P3, is that you can unleash innovation at an even faster pace to come up and try and test new ideas, to put new things to the test and get the results quickly. So we've been able to train the ResNet 50 to top 1 validation accuracy at 76% in just 47 minutes using 8 of the P3 16x large instances. So this is incredible performance improvement. And what it really means at the end of the day is much lower cost. When you think about all the costs of operating these and being able to have the staff and all of your data and the things that are waiting in order for those results, you're really reducing the cost to be able to handle a certain amount of work. We also have the broadest availability. So now in 14 regions, we have across all these different regions, we have P3, and the largest sizes in US East and US West. So that now more and more countries and regions can take advantage of this. This is particularly important for areas where the data set being processed needs to remain in region for compliance or regulatory requirements, and also just to speed up the workflow for teams that are located in those different geographies. And by the way, those are available on Spot as well. So if you're looking at the largest instance sizes and you're saying, how am I going to afford that? Take a look at Spot. You'll be surprised that with up to 90% cost savings, it's amazing. You can just spin one of those up and start right away with using that. And it's a really great way to get introduced to the AWS platform and start using machine learning on the cloud, is with these really fast instances. The only trouble will be going back to your own laptop or desktop after you've seen the performance of these. It's amazing. So in terms of storage, of course, your machine learning needs to be fed a lot of data. Data is what really is the heart and soul. So you've got to feed a lot of data in. And how do you do that? Well, there's several different options. So we have EFS, the Elastic File Storage. And this is highly available multi-AZ file storage that's there for you. This enables you to do read-often temporary storage, and this is great for highly available storage in NFS format. Now you've also got the option to use EBS, and you can actually connect multiple EBS volumes to a single instance, so you can mix and match those, but it gives you the kind of IOPS that you need in order to saturate your GPUs for high I/O performance. And now with S3, we offer up to 100 gigabits ingestion from S3. So talk about loading up your data really quickly into do machine learning workloads. You can actually store in S3 and get very, very fast load performance. And now with Glacier, you can archive that data off that's been processed, where you've fed it into your machine learning model and you don't need to look at it again for a while. You can archive that longer term at a much lower cost point. And then we recently announced Amazon FSx for Lustre. This is a shared file system for high-performance computing. So this enables a lot of use cases of P3 and our C5 instances where you need to have that shared file storage to keep the job state or to be able to pull data in for these different jobs. And in addition to that, we also support Windows File Server with Amazon FSx. So it's actually Windows native. This is actual Windows file server hosted on the cloud, and it's fully managed for you. So there's no need to manage that file server. Performance is very fast, and it's secure and compliant. So it gives you Windows native capability for compatibility with the industry standard SMB protocol. So if you have software that uses that, you don't have to worry about detecting or correcting hardware failures. It does that for you automatically, including performing regular backups. And it's secure and compliant. So it's PCI DSS compliant. And it's the first service to be both PCI DSS and HIPAA eligible at launch. So this can be great for protected health information or other sensitive data. And it delivers really fast performance, so up to 10 gigabytes per second of throughput across petabytes of data. So scales really nicely. OK, so in terms of data ingestion options, here are a couple. So as we talked about briefly before, you can attach multiple EBS volumes to your instance, and you can provision the IOPS on those so that you can get the maximum saturation of your GPUs that you need. So you can either use an independent EBS volume or combine multiple volumes via RAID. So that's a couple different options that we've seen customers use. And then the other one we mentioned briefly is you can configure S3 to connect to your EC2 instance. And that's a very fast way to ingest. And you can use the S3 Java SDK to do that, to pull in those data. So in terms of software support, you need these hardware driver versions. So you need 384.81 or newer, the CUDA 9 or newer driver. And these are, the CUDNN 7 or newer is usually packaged with CUDA, so you need that as well. And then in order to take advantage of all the cores, you're going to be needing to use the latest ML framework distros. So make sure you get the latest versions of those, but we support all these different versions of TensorFlow, MXNet, PyTorch, Caffe2. So take a look at those docs, the NVIDIA docs for specifics, but make sure you get the latest drivers and are using the latest frameworks to be able to get the maximum performance. We also offer our own deep learning Amazon machine image. So we basically provide to you a machine image that comes with all the latest frameworks, and that just helps you maintain and manage all of the dependencies to make sure you have the latest versions installed and that you're getting the best possible support in terms of drivers and of being able to tap into the hardware performance. So we have some great customer examples using machine learning. So for example, ZocDoc uses machine learning to help with patient scheduling. And they actually have two different use cases in production right now. One is patient-powered search. So it basically helps quickly find the specialist that you would need for the service you need. So it uses a semantic model. And it basically maps the intent of your search to a specialist. Because sometimes the terminology in healthcare is kind of foreign to us as consumers. And so consumers can just type in words and it'll understand the intent of what you're looking for. And it uses inference, but they build that machine learning model using this Amazon machine learning image. And then they have a relevancy model to help find the most relevant doctor in your area. And then the new thing that they've added recently is an insurance checker that helps to leverage AI to make sure that you're getting the best possible insurance coverage and then taking advantage of your current insurance to understand the coverage better. So it'll scan your ID card and based on that be able to identify who's in network and where you should be going for those appointments. Okay, so Amazon SageMaker takes advantage of P3 instances. This is basically end-to-end machine learning platform for you on AWS, so you don't have to do any setup. It's fully managed for you. And what's great is it'll even tune your model by doing the hyperparameter optimization for you. You just pay by the second for the machine learning, the model development, and then in execution. And what's great is it gives you a way to put your model into production because typically those are two separate steps. And with SageMaker, you can actually go from building and creating your model, tuning it to now going into production and being able to update it on a regular basis with the latest data that have come in. So a lot of customers have seen this as a great way to, especially for people who are new to machine learning, to help them understand the concepts and get up and running with it quickly. So if they need Jupyter notebooks, they want to share some data and be able to collaborate and then be able to push that into production, there's usually several teams involved with that whole workflow. And SageMaker simplifies that pretty dramatically. And especially for developers, sometimes for developers, it feels like machine learning is a lot more difficult than it needs to be. This enables your developers who already have skills with different languages and frameworks to quickly get up and running at scale on the cloud. Okay, so let's talk now about G3. So these are for graphics intensive use cases and include up to 4 GPUs in these instances. So with the G3 16X large, you've got 4 GPUs. Those can be dedicated to a particular workstation, or you can actually virtualize using the grid software that is included, the NVIDIA Grid virtual application, to virtualize these applications so you can support up to 25 concurrent users per GPU. So this can be a great way to build a graphically intense application on the cloud, render it on the cloud, and stream it back to those clients. We've seen this used in a number of different cases, such as 3D visualizations, particularly for if you're doing some sort of workstation or 3D rendering, this is a great way to do that with industry standard software. And then this slide shows a little bit about these 4 different modes of using the G3. So you can take advantage of the memory, CPU, networking, and GPU across these different use cases. So one is video encoding, for example, using the EC2 instance and the NVIDIA drivers. Then you can use the NVIDIA grid for like a workstation, a virtual workstation. And then rather than having to buy a massive physical workstation and install this, and you can actually put it to sleep, as we talked about the hibernate capability, works so that you can put that instance to sleep and not pay for it when it's not being used. And then you can also set it up for up to 25 concurrent connections for these virtual apps so that you're taking advantage of all of that capability across many different end users. And then we've also seen it used for gaming services as well. So you can build custom gaming solutions that use this as part of the rendering. Or maybe for collision detection, things like that, where there's GPU required and some rendering as well. So here's the comparison of the workstation versus the virtual application modes. So you can see it can support up to 4 monitors. So again, it comes with up to 4 GPUs on the G3. So you can actually have a 4-monitor workstation, all powered virtually in the cloud. And this is a use case we're seeing especially with studios and media and entertainment, as well as in engineering and design, that customers are able to do this. And it just saves on the upgrade cycle. They don't have to wait 4 or 5 years for that normal upgrade hardware cycle. As soon as we have new graphics instances in the cloud, they can just immediately use their Amazon machine image and start it up. So here's some of the available marketplace offerings that you can get to run with these G3 instances. So we have Windows Server 2016 with the NVIDIA Grid driver, for example. And then those first 2 are no additional charge. For some of these, with the Grid driver, you're going to have an additional fee, but you can launch them straight from the marketplace with all the software pre-configured in the Amazon machine image. So let's talk about some of the use cases. We talked a little bit about energy and oil and gas seismic analysis. So Halliburton was a great example where they needed to render this oil field, 3D visualization of that. And in order to do that, they were able to tap into those 4 GPUs on the G3 to be able to render it in real time. And it gave their team such an amazing new perspective on this data, because typically it was difficult to render it, especially in real time, to be able to move and manipulate it and see it. And so if you have use cases where you can take advantage of GPUs for graphics and rendering, G3 is phenomenal. Okay, so now let's talk about F1. So F1 is our FPGA instance on the cloud, and this is basically for custom hardware acceleration. So FPGA is very good at processing massive amounts of data in parallel. And what's great is the FPGA does not come with an instruction set. So it doesn't have a fixed data width path. It's very flexible. Of course, it requires some skill set to program it. But there's no complex control logic, and you can run millions of these things in parallel. So now it gives you the ability to do a lot of video processing. We've seen it used for encryption. We've seen it used for things like genomics. And so as an example of this, Edicode Genome, which has now been acquired by Illumina, they were able to set the Guinness Book of World Records for the fastest processing of 1,000 human genomes by spinning up 1,000 of these in the cloud on AWS. So they were able to spin up 1,000 of these simultaneously and able to set a new record, processing 1,000 genomes at an amazingly low cost of approximately $3 per whole human genome, which is just amazingly inexpensive. And they did that with this fixed size. They basically created a, rather than the fixed size data width paths on the CPU, which is 32 or 64-bit, they were able to use a custom bit data path to be able to maximize the throughput. And basically, they saw a 30x speed up because they were able to encode that algorithm on FPGA. Okay, so these are the FPGA instance types on AWS. So there's 3 different instance sizes available with up to 8 FPGAs, each with over 2 million field programmable gate arrays or logic units, and 5,000 programmable DSP blocks. Now, one of the things that has been introduced recently is the ability to quickly load new Amazon FPGA images into that FPGA, and you can have multiple on each instance. So we've recently launched 2 new instance types, one supporting up to 8 Xilinx FPGAs. And we've added a lot more local NVMe storage, SSD storage, so that you can store a lot more of the data that you need, because that was one of the customer feedbacks that we heard was, hey, in order to process all of this, I need to be able to cache some data on the instance. And so we've added a lot more instance store. Okay, so there's 3 different ways to use F1. So first of all, if you have hardware engineers, of course, the tools they're familiar with, like Verilog, they can create their hardware designs, their FPGA designs, and deploy those using the Verilog and VHDL. For software engineers, those who are not necessarily that familiar with hardware development, they can now use the OpenCL C++ library to be able to convert these algorithms into hardware instructions. And then for software engineers and developers, if they're not proficient in FPGA design, they can also use pre-built AFIs on the AWS Marketplace and just be able to call into those to get the speed-ups that they need for various functions. So here's an example. So for an F1 instance, you're going to load an AMI, a machine image, just like you would on our other instance types. And then you're also going to load an FPGA image or an AFI, an AFI. And the AFI can be loaded in just a few seconds. So you can actually store multiple of those AFIs on the instance and swap them out. So if you need to do video encoding and decryption, you can use a variety of different algorithms. You can just cache those on the instance. And the Xilinx card actually has onboard memory to store some of those images so you can quickly swap them. And there's a great set of tools. There's a FPGA developer AMI that's available in the marketplace that comes with the tools pre-installed so that you can develop and debug and deploy all of these and test it out. And then once you're ready, you can make it available on the AWS Marketplace and start making money for converting your algorithm into a hardware accelerated AFI. And so with OpenCL, this is a big improvement. Now you can use C and C++ to be able to create new hardware accelerated AFIs and bring your algorithms to the cloud. So if you have proprietary algorithms and you would like to accelerate those and make those available to other AWS customers, you can do that using the OpenCL. And there's no need to upgrade or install anything on the developer AMI. It's already part of that. So you can grab that from the marketplace. So here's an example from the marketplace. So you can go up there and search and find the existing options that are available from third parties as well as from AWS. So you'll see the developer AMI is in the upper left there, and then you'll see a variety of other offerings now on the cloud. And we'd love to see your company or startup put some offerings up there and make those available as well. Or you can take advantage of the ones that are already up there in your applications. So again, delivering these to as a partner delivering these solutions, we have the machine image, and then you can deploy via the marketplace both the AFIs that are encrypted and secured, so your algorithm is safe. If you put your proprietary algorithm in there, it's encrypted and secured, and then both of those are loaded simultaneously into the marketplace and pushed out to their instances as they deploy it. So they never see your code, they'll never see your algorithm, but they'll get the speed up that that you're able to deliver with the Xilinx FPGA cards. So again, there's a summary of our accelerated computing instances. So we have P3 for GPU machine learning acceleration, the G3 instance for graphics intensive rendering applications, and the F1, which is our FPGA instance in the cloud. So again, we're putting a wide variety of different options out there in terms of processor architecture and in terms of parallel computing and accelerated computing. And the goal is to enable new innovation that hasn't been possible in the past, and that you're going to help bring to to AWS. So please connect with me right afterwards. We'll love to help answer your questions and also connect you with some of our solutions architects to design your solution or help with your migration, and also to hear your feedback and needs in terms of capabilities on the cloud. Again, we want to deliver, our vision is to bring compute around the world wherever you need it, and to provide at very low cost and the scalability, performance, and availability that you need, and do that in a secure way. So thanks again for your time today, and look forward to chatting with you afterwards. Appreciate it.